Oh, Ethan, any questions? I believe we have finished 3A last week. So do you encounter any issues? Yes. Okay, for question 3, reminder, octane is a liquid, it's not a gas, so don't use the gas formula for octane. Just take note of that. Make sure you know what your substances are. Oh, Angel, question? No. Okay. Ethan, do you manage to get B part 1? Calculate the molar mass? Yes. Didn't? Okay. So if you were the one, make sure you return to me later. Oh, Dylan, done. No, no question. Yeah. Okay. Oh, one name. Okay. Now, let's take a look at this section C1A. Why the experiment was performed in a fume cupboard. First thing, can I assume you all know what is a fume cupboard? Fume hood? No? Yes. It's a big cabinet, and then you perform experiments inside. Basically, the air is sucked up of the cupboard. It's basically sucked up all the way to the top of the building. So, first thing first, fume cupboard in general is for safety. It's to protect the user during the experiment. Now, of course, it's to protect the user against exposure to chemical substances. As I said, the air is sucked into the cupboard. That means nothing by right, nothing escapes from the cupboard to the user. All right, you're just facing this big cupboard with a glass panel in front. Now, what you need to know is this. They did mention this thing. Bromine has a melting point of -7 and a boiling point of 58. Why do they mention this about bromine? Now look at here, there's a heating. And under ordinary heating conditions, you will expect the temperature to go above 58. Okay, here it can easily go all the way to boiling. I mean, water boiling temperature. So that means your bromine is vaporized. But, oh, before I forget, do you remember what's the state of bromine at room temperature and pressure? Now, if you look at your periodic table, there are only two substances which are liquid at room temperature and pressure, two elements. Which are the two elements? Guys, you're supposed to know that. One is bromine. The other one is, Ninja, what's the other one? Liquid at room temperature and pressure. Elements. Gallium. Okay, good guess, but no. The other one is mercury. Okay, maybe you don't have to know now, but sooner or later you have to know that. So anyway, they already give you this information, so it's fine. So by right, bromine is a liquid at room temperature and pressure. But because of the heating, it vaporizes. So you need to know this about bromine is toxic. Whether as a gas, liquid, or whatever. But because it's done in a fume hood, all right, okay, I write it in full for you. Basically, the hood, the fume cupboard can use fume hood. All right, the fume hood basically prevents your bromine gas or bromine vapor from escaping. Into the laboratory. Let's assume this is done in the lab. So just remember the fume hood is basically for safety, but in this particular case, is to prevent bromine vapor from escaping because your experiment involves bromine vapor generated. Now, the second part is a condenser. Why do you need a condenser here? Is this distillation? Nope, doesn't look like distillation. It's not. But remember, we mentioned bromine vapor is formed, so you would expect your bromine vapor to rise. Okay, but do you want it to escape? No, you don't, because what are you doing here? You are performing an experiment. So these two guys are your reactants. You do not want your bromine vapor to escape because it is a reactant. And therefore, that is the purpose of the condenser. The condenser basically condenses the bromine vapor back into a liquid, and it goes back into the reaction flask. Anyway, just to phrase it into nicer words, okay, basically the condenser condenses bromine vapor back to liquid. Okay, which drips back into the reaction flask. Okay, and bromine is a reactant. It should not escape. All right, so that is the main consideration when you have a condenser on top. But of course, there's a secondary consideration, which is the safety. Again, you want to minimize escape of bromine vapor. The condenser helps, even though it depends on how you set it up. It may not help 100% with regards to the safety aspect. Oh, guys, can you add for the part one, make sure you mention that bromine is toxic. So prevents toxic bromine vapor from escaping into the laboratory. Okay, keep that in mind. You may just be asked about all these unusual questions. Usually it's about toxicity or some sort of hazard. Ethan, okay? Inja, order. Mm. Number one, part B is a bit ambiguous. You don't really have much information to put on. You have to make some assumptions for part B. Look up the masses of copper and bromine that have reacted together. What two other ratios need to be taken? Okay. This one. This one. Does anyone have any idea? Part B is a bit ambiguous. It's quite ambiguous actually. You have to make certain assumptions. Oh, the rest all done. Okay, but let's look at the calculation questions. Let's skip the part B first. C part one, I assume all of you should be able to do it. And breaker formula, the compound between copper and bromine. Okay, basically convert this to mole. Convert this to mole. And then find out the mole ratio between these two values. Now, the only thing I want you guys to be careful, bromine, what's the formula? You're expected to know bromine is Br2. Don't forget the 2 there. Okay, when you work out the MR, that's the only thing I want to warn you. So if you do it properly, you should get this answer. That is the empirical formula. Now, as for C part 2, what further information is required to find the chemical formula of the compound? Yeah, again, this question is a bit ambiguous. Doesn't really give you much to work on. Actually, for this case, the answer is basically the MR. Okay, so you need to know the MR of that compound between copper and bromine. Okay, number 2. Have you finished it? Ninja, done. Ethan, done. You all get the answers here? Oh, okay, that's good. Dylan, still working on it. Now, at the same time, check the answers for this question 3. Make sure you get all of them. Okay. Then, okay, sir. Okay, for this one, probably I'm going to skip it because this is quite ambiguous. All right, you don't really have a good answer to part one. Let's make quite a few assumptions. Right, I'll skip it for now. Okay, for the rest, any issues or questions regarding them? Fine. Dylan? Maya? Maya? Okay. Now, in the case, let me just give you a random question. Which should come up? Very simple. Make sure you know the principle behind it. Now, let's say I have this guy. You should recognize what it is. Ethan, what is this? Mhm. Now, very simple. I want you to calculate the percentage mass of nitrogen in ammonia. That's all. Make sure you understand what I'm asking of you. Now, of course, if you don't understand the question, voice out. Hmm. So what you're supposed to do? India, got it? Okay, okay, good, Dylan. What's the answer? Okay, can. Now, guys, what it is asking is this. First thing, find out what's the AR, atomic mass of nitrogen. Look at your periodic table, it's shortened, and there's only one. Find out what's the MR of ammonia. Okay, work it out using a periodic table, it's 17. So therefore, to find the percentage mass, you simply take 14 or 17 times your 100. All right, so we should get your 82.4, right? Yeah, 82.4%. Okay, so make sure you understand this kind of question, which can definitely come up. Now, let's give you another one, which is, by now you should know the procedure. Okay, let's say I have this. Reminder, this is ethanol. Sooner or later, you have to remember this. Okay, so very simple. Find percentage mass of hydrogen in ethanol. Oh, Ethan, got it? You cannot wait for Dylan all the time. And answer, Dylan?
4.35%.
4.35.
Wait, 10.9.
10.9.
10.9.
10.9. Major? 13. Okay, that sounds better. Come, guys, work it out carefully. Yeah? You have 5 plus 1 hydrogen. Those, there are 6. So 6 times 1. Yes, it should be 13.0. Please remember this sort of questions. They very well can come out. Okay, fine. You don't remember. Now, this is what we did last week up to formula number 8. I have only 2 more formulas for you, and that closes the chapter on mole concept. Right, number 9. A percentage U. Some Dylan can remember the formula?
That some things
Uh,
like theoretical risk.
yeah, there's something about theoretical, but something about actual as well. So it's the actual amount of, take note, I qualify using this word desired product. Your reaction may have more than one product. You're supposed to find out from the question which is the one you want. Again, don't mix up numerator and denominator. Theoretical is denominator, actual is the numerator. Okay, what else? Now, I use the word, okay, as I said, desired product. Find out from the question, which is the desired product. What about amount? What units should you be using for amount? Yeah? Well, of course, you can use grams. Now, if you use grams in numerator, make sure you use grams in denominator. Make sure that. On the other hand, I can also use mole. Same principle applies. Mole above, you must have mole below. Okay, don't mix up on this. Now, occasionally, you can use volume. This is only for gases. But of course, volume above, volume must be below too. Oh yeah, of course. I mean, I didn't really spell it out, but if you're using volume, make sure your units above and the units below are the same. cm cube above, make sure you use cm cube below. Okay, so formula looks easy now, but usually the question is not so easy. Never mind, later if you want to try out. That's the formula number 9. Last formula for this chapter is percentage purity. Now, this one is quite specific. You can't just use amount. You have to use mass. Most of the time. there are some exceptions regarding gases, but I won't touch on that until you see the question. Mass of pure substance. Kilo mass of pure substance. Since it's a percentage, make sure multiply by 100. Now the same principles apply. Obviously, if you use grams above, make sure you use grams below. If you kg above, make sure you use kg below. But for chemistry, kg is not so commonly used. And in case you haven't figured out by now, both of these values must be less than 100%, less than or equal to. Same thing for this. Okay, anytime you get more than 100, obviously something is wrong. All right, so yeah, that's the formula part. Try not to forget them, but applying them is a little bit more difficult. I'll give you one question. But the good news is these two kinds of questions are not that common. Okay, they are not that, you don't see them that much. So I can only, okay, I didn't print out for you, but I think it's easy enough to work on what is given here. Okay, so it's a percentile question, obviously. Now, the good news is, look at my reaction, there's only one product. So therefore, you don't have to figure out what is the desired product. There's only one product. Oh, this is a typo-ish error. Okay, but if you ever encounter more than one, you need to look at your question to figure out which is the desired product. And just to add more context, 3 grams of magnesium oxide was obtained. So it goes without saying, make sure you interpret correctly. This 3 grams is your actual amount of product. It's already given straight to you the actual amount. Your job is to figure out the theoretical amount and then make use of the percentage yield formula. Now, of course, you have to use the 1.92 grams to do something about it. Well, if you're not sure what to do, I think the first step, of course, try to find the number of moles. That means you divide by AR. All right, so in this case, it's magnesium. Okay, I'll let you all find out the number of moles of magnesium. Okay, based on this, find out the mole of the product, theoretically. And after that, you find out the mass. Right, you just got the answer? Number? It's 94.3.
Mm.
94. Oh, Dylan, you get it?
Oh, I also got 93.8.
I think there's must be a truncation error somewhere, so should be fine. Okay, let me see what the actual values mean. It must be a truncation somewhere, so obviously, yeah, because your for the AR magnesium, I believe you use 24. Yeah, confirm that's one. Because they use another periodic table that is 24.3. All right, so yeah, you find the number of moles of magnesium. Subsequently, you find the number of moles of your magnesium oxide, which is the same, and then you find the mass of the magnesium oxide. That would be the theoretical amount. Now, if again, just to make it very clear, most of the time your theoretical yield has to be calculated. Most of the time, that is how the question is set up. Ethan, okay? Yeah, okay. Now, how about this one? This percentage theory question. I hope you catch a few clues here. I want to emphasize this phrase, burn completely. You know what's the implication when they say that burn completely in air?
Limiting.
Yes, good. This is limiting. And of course, that means your oxygen is in essence. It's not obvious, but usually this, let's say, sorry, not usually, this value here or this substance here is impure. So 0.7 grams is an impure mass. It's not totally made up of impurities. It doesn't mean the entire 0.7 grams is in. There is some impurity inside. Now, the logical thing to do is make use of this to find out the mass, back calculate to find out the mass of it. But in between, you have a few steps. It's not a direct calculation. what to do first? You're given mass. Don't think too much. Just find out the number of moles of CO2. That should be the first step. If you don't know what to do, find out moles. Oh, 90. Okay. Angel, do you get 90? Okay, that should be fine. Right, so if you don't know what to do, you're given mass here. Okay, let's go find out the number of moles of CO2. Right, 0.045, then work out the moles of ethene. Ratio is 2:1, 2:1, so this is ethene. But remember, I stress again, when you use this formula, percentage purity amount has to be mass. Most of the time. There are a few exceptions, but I won't mention those exceptions. All right, it's in mass. So find out the mass of pure ethene, 0.63. Put in the numerator, mass of impure ethene, given in the question, 0.7. Yeah, let's look it up. Make sure your answer is less than or equals to 100. Okay. Yep, guys, any questions on this? No? No one? I expect you guys to be very well versed in all these calculations.
Right? It's model like it is not. It's not. Alright, if I give 50% this one. Now this partner give 50%. So it's fine. Second one then yes. Then this one is fine. Oh, like this. Okay. Plus 7 over 10 x 5 plus 6 and yes, three to 20. So that still you try to understand. Okay, we keep it up. Your next. No, I cannot tell you this. Okay, we do not by this expectability the next. Okay, to understand. If I keep 40% away, right, of the figures, it will go back. 40% will go back. Okay. If I keep 40% of the figures, right, it's more over that one. Because okay, I can just pick this as 10 over 10 is what? X1, right? Right. Say if I give 4 over 10, because it's 40%, correct? Now you tell me this one. Right? Then I'll get over there. 30, okay, 30. If I give 40% of 30 is fine. So you manage how much you get. Okay? I don't. Okay. You know why you get X factor because no. Okay, you assume this person got X because that is what he is but his brain will malfunction. So that X be something that X be something on this one is okay. We have to and one X is supposed to be. This one oh yeah, this one. Okay, that's all next in the answer. Then number 4. Okay, what? Tell me what is 6 over 10 plus 7 over 10. 6 over 10. One whole 3 hours. This is what? Plus 6 plus 18 plus 6, 18 plus 6. 24, yes. 21, 24. Okay. Plus 6. 30, 30. This minus this is what? Oh, shit. Now you see, okay. So this person is 48 more seconds than this. Then how do you go? Right? I don't know. Yeah. But it's like that. So you how you come to you need to solve it. Okay, how? Solve it. The way to solve this is to solve it. Okay, then you come right. So the way to solve it is to give the answer. Then my point to people you structure that. Okay. Yes, I don't model and not don't model. Okay, that's it. Most like I said, everything to answer. But we will get like saying something exam. Or it's reason. That's right. This right. Don't mix model, right? Okay, so now this person is what? The model more confusing. Yeah, see? You will make this model more confusing. Algebra is confusing. Yeah, my brain got algebra, his brain got model very different. Okay, later I do model for you, okay? Yeah, this one is something not. This is 48 more than this, so how do you solve find the equation? I don't know. Okay, let's say right. This whole thing here is this. Okay? This here is this. How do you solve? Is it? Huh? Huh? How do you solve? Okay, see right? This whole thing here. Okay, wait, focus, ah. Hey. Okay, listen. So you are now get 48, right? This whole box here is this. This one times 2 plus 48. Okay, yeah, this thing here minus 48. I don't know. Yeah, then you go with everything. What to do plus 48 is the okay, who has the 48 more? This person or this person? That person. This one, right? Yeah. Okay. So if this one has 48 more, this has minus 48 here, right? But you make it the same, right? Okay, then how yours? The English. Okay.
That's the same.
Make this visualize. Okay, wait, I draw for this person, so okay. This person one more with this. This person is this. Okay. Is that right? Can we visualize? Then this one white square is this. I don't understand how you understand.
One question.
Okay, wait, talk about this one.
Okay, for any reaction, always think about anything reaction. Is there anything reaction?
So just bring this here.
Okay, you have to identify it, otherwise you won't get the right answer.
Okay. Yeah, also can. That method will not okay. Okay. Or you can think okay, you still got it here. Okay, or you can bring this thing, that thing here. Because this and this is the same thing, right? What thing? Yeah. Okay. This is one part. Okay. This okay, then this rectangle, right, is equals to this rectangle, correct? Somehow. This and this is the same, okay? If I bring this over here, means what? 7 over 10 x plus 6 plus 48 is equal to what? No. This whole thing is equal to what? I don't know. 13 over 10 x plus 21. Okay. That's it. Or you can follow her method also. This minus this equals to 48 also can. Okay, which part? This part. So this part is everything, is it? Okay. This person has 8 more circles than this person, correct? Yeah. Okay, this is the total. So one rectangle plus 48 will give you this. Correct? One rectangle is equal to this. And then, so your friend's method is you take this whole thing, you minus this rectangle, isn't it 48? Alright? Or you can do this rectangle over here plus 48. Okay, which part? Okay, I kind of think don't kind of think time is solved.
Ethan, any question?
Okay. You should understand how this part and this part of the balance. Oh my god, this is okay. Okay, then you try solving it on your own first, can? No. Try doing it. Oh, I know the answer number 4. This is not how solve the plan. That isn't good and how to get okay, so I got 25% try. I will guess like 2 questions. Okay.
89 years ago, I got 87 in my university.
So you get 87. Very people, okay, in exam, if you all really don't know, okay, let's do one by one. Okay, or do your second gym. This one, okay, one is the mean out, first one we have 30, correct? Yeah, do it out. So if you all really don't know, okay, just put in the values in the exam. This make yeah. If I really don't know, I guess, but 25% chance I think, correct? Yeah, I thought we are somehow very.
Question 3, you have, even though it's not written out explicitly, you have to assume that your nickel sulfide is limiting you.
Yes, okay. Okay, folks, you see, right? If I put in the values, now this person has 50, right? This person means this person got 20. So, it's correct, right? Then you just solve accordingly. If it doesn't, if the answer doesn't make sense, then you just go with it. You don't really know. Can? Okay. We don't continue the paper. Do the rest. Any other questions? Yeah. Okay, and this one, anything else you need? I will do your two. 1, 2, 3, anything else from the okay, I'll continue with the paper.
For question 6, make sure you understand what is meant by hydrated cobalt sulfate. It means that the formula will look like this: cobalt sulfate with a full stop and bonded with a certain number of water. So the unknown is this: how many water molecules there are. That is the number you need to figure out. Okay, that's the meaning of hydrated salt.
Your paper and read the question. Understand. You have to finish the paper by day. 1 hour eh? No 1 hour. Okay, hello. So this one. Oh, don't worry, I'm not. Why so much? Yeah. No. So little can go through. Sit no. Oh, wait, you're doing it for me. I'm going to pass it. Okay. You're trying to do it because don't find what's now. I will. One, because the whole how we can do 7 and 8 hours. I enjoy so let's say
Gets better. That's the biggest equation. Find out.
One speak right, so one country around. And can see spaces about to how I might not design how space. Because it's that language to look at.
For this two rectors. Let's say
One get each. So we have how many gets? Like eight, then the total is what, eight? Right, so minus the same as the two. So you just say, no, you actually. Yeah, I finished that. I have eight. So how far you do something? That is you don't speak music, that is before you start like the or what?
All the sleeping pattern is
Yeah.
fully.
Why as is my name was it correct? It was I know. Because
Isn't correct? Yes.
This angle and this angle. Or property belong or the person. Belong to the world, you know already. Long time is and is. This is it. Easy. What not right here that is the last one to stay on same. Yeah. Yeah. You teach they teach and basically it's and it's it's heavy. No. If I saw it's I got this one. Don't next week. Next week. No, it's yeah. No, next one. Okay. My statement is wrong. Because A, B, and A is right, is wrong. It's not correct. There's no same angles. Right, minus three. Alright. They went alright. Yeah, that's great. I can see up close. They go, they now. They have to explain to me to extend. You have to parallel lines. They want to, yeah, okay.
Okay, guys, for question 7, there's a trick involved. Notice that phosphorus is a vapor, chlorine is a gas, and that's important because they also mentioned these two have the same volume. Now, same volume of gases or vapor implies the same number of moles. Keep that in mind. If two different gases have the same volume, the implication is they have the same number of moles. If you remember your gas formula. But of course, reminder, chlorine formula is always Cl2. Don't put Cl2. So your job is to find out what is this formula. Is Px, but you don't know what's X. Your question wants you to find out how many atoms join together to form one molecule of phosphorus. Okay. Any questions? Ethan? No? Right, bring this paper along next week. We shall finish it off. Right, any questions for today? No? Okay. Then we shall end it here. Okay, don't forget the return the periodic paper. Hey, Dylan, that time you said your school is teaching socks now, right? Any particular questions on it?
Any particular questions? Okay, we're just going through the matter.
Okay. And your side, what's your periodic paper? Oh, yeah.
Yeah.
And the same that for a while, I easily through on the detox one. But you go to the counter because there's another class coming to take this. Okay, bye. Bye. Yeah. K-pop people are well, I mean, my stuff.